Okay, so hello friends. I'm Vijay. I'm doing my master's in structural engineering from IIT Hyderabad. Today we are going to see how to analyze this beam in ETABS. This is a beam. We have a fixed support, roller, and roller support are applying the loads. And here we are having load at 3 meter span. And here we are having load at midspan and midspan. So let us see how to analyze this in our ETABS. So go to ETABS, new model, and you have to use built-in setting. I am going to make it metric SI and Indian, and then I'm going to steel design code, that is IS 800, and for concrete I'm going to take IS 456 2000. Okay, now actually these things are not needed. See, we are going to analyze the beam, and the beam is like so I will show you. I will use custom grid data, and in that we have to analyze the beam. So what I will do is I will I will delete these things. Okay, so you can see here I will have only this thing, and how many grids I need in this y direction, that is a b c d x grid data. Let us see that. See, one at point a, b, c and d, we need four only. Okay, so we have a b c d 4, and this is one line, that's fine. So we need to assign the spans. So what the spans are there? Display grid data as ordinates, we will display it as a spacing. So what are our spans? Our spans are 5 meter, 5 meter and 5 meter. Okay, so our spans are like 5 meter, 5 meter and 5 meter. Okay, so this is 5 5 5. Now press OK. You can change the bubble size from here. This is the bubble size of these notations. And actually we are not casting, or we are not modeling a building over here, but still let us suppose that is a one floor of a height 3 meter and grid only. Okay, now you will see here that the grid system will be shown here in plan view, and here you will find it in 3D view. Okay, so what we will do, we will this is a plan view. You can see this is a plan view of story 1. We want a elevation view, so go here, elevation, and we will have the elevation at this point 1. So click apply and then OK. So we are able to see now. We can close this. Okay, so that we focus more on what we want. Okay, this also we will make this like. Okay, now we can see this is base and this is story 1. So we are going to cast our beam over here on the story 1, and we'll analyze it. So first of all, you have to, we are not going to define any materials and things, and we are, because we will see that when we will be modeling a building. But now we are just looking for how to analyze a beam, just like we were used to do in our structural analysis. We don't know what the type of section we are using. Okay, so you can go here and draw beam, column or brace, and from here you can draw, or otherwise. Okay, so this is the section, and we don't bother about it right now. Or otherwise you took it from here, otherwise you can go from here also, that is a shortcut. This to this is a 5 meter span, and from here to here again 5 meter span, and here to here again it is a 5 meter span. So now to get out of this, right click on your mouse, so you are out of your command, and now you can close this. Now we want to assign the joints. Okay, so you can press escape button to come out of the command. Now we have to assign the joints, so click here, go to assign joints and restraints. Here you can see this is our fixed roller and roller. Okay, so we have three types of joints. So our A joint is fixed support, so this is the fixed, and you can see these restraints apply. This is the fixed support over here, and other three supports are roller supports. So just select these three supports and make them roller, apply. Okay, press OK. Now we have to apply the loads. So what are the loads? Loads are 30, 40 and 50. So 30 kilonewton at 2 meter. Okay, 30 kilonewton at 2 meter. So assign, and actually we are going to beam is nothing but a frame, so we are going to apply frame loads, and the load is a point load. That's why we are going to take point load. So now we have to select the beam first. This is the beam we have been selected. Now the point dead load, it is a dead load, and force in the gravity direction, that is downward direction. There are two options: relative distance from end I and absolute distance. We will take for the time being we will take absolute distance. So we are selecting this beam, and now we will apply. Okay, so now we will apply. So see, at this beam, 0 is nothing but here, and at 0 we don't want any load. And we want at 3 meter, this is 3 meter, we want a 30 kilonewton load. So just press apply. So yeah, you can see here at 3 meter the 30 kilonewton load is applied. Now here we have a load at 2.5 meter, 2.5 meter, that is nothing but at the mid span, so 40 kilonewton. Now we will try to apply. First we will select this beam. Yeah, selected. Now we will try to apply the beam load using this method. What is this relative distance? So it considers as this beam is a 1 meter long beam, and we have to apply load. So at 0.25, that is nothing but it is a 5 meter, so at 0.25, that is 1/4 of 5 meter, it is a 0 load, and we want to apply actually at 2.5 meter. At 2.5 meter, that means at the mid span, so we have to take at 0.5, because we are taking the relative distance and we have 40 kilonewton load. So apply. Otherwise you can take this as absolute distance, and you can make this as 2.5 meter. It will not make any change. We can do that in the third span. You can see in the third span we have 50 kilonewton at 2.5 meter and 2.5 meter from both the ends. So select this beam at 2.5 meter, 40 kilonewton, and other things we have 0 0 0, and apply. So you got sorry, we want 50 kilonewton over here. We want 50 kilonewton. So what we will do, we will press 50 kilonewton, and it is replace existing loads. If you add to the existing load, it will become 40 plus 50, that is 90. We want 50 only, so now apply. Okay, so we forgot to select the beam, so now we have selected the beam, and now apply. Okay, so this beam is now load is 50 kilonewton. Now just you can before analyzing, you need to save the file. So we will save the file. We will save file as beam model. Okay, and the file is saved. Now the point is we have to analyze. You can run analysis from here also, or you can press F5, or you can go here and run analysis. Now it will show you the analysis. It will show you the deflected shape in 3D. You can rotate this by pressing your scroller and shift button simultaneously and rotating it. We want it to be here, so we will click here, and this is the, you can say, show deformed shape. So press OK, cubic curve we want, and OK. So yes, this is the kind of, see, this is the fixed support. You will get 0 slope, and it is showing all the things over here. Okay, at the support, what is the reaction and all those things. But here what the point is, we have considered the ETABS has considered the self weight of beam also. We don't want to do that, so we will go into define, and we will define load patterns. Here we will have to make this okay, so first of all, what we will have to do, we have to unlock the model, so that our analysis results are gone, and now define, and then go to your load patterns and make this as 0. Modify load and make this as 0, and then click modify load. So now ETABS will not consider the self weight of the beam, and what it will only calculate the SFD and BMD based on our applied external loads. Okay, so now we will again apply the load, assign frame loads and point load. So at we will take absolute distance at 3 meter. We were having 30 kilonewton on this beam, so apply. Okay, so the loads are regained over here. Now just run analysis. Yeah, you can see the deflected shape here, but we want to see it here, so you can go here and press OK. The deflected shape is here. Now if we want to see the diagrams, so yes, you can click over here. This will show us. See, if you want to see shear force diagram, so we will look the shear along 2 and for the dead load case. Okay, apply. So this is the shear force diagram, you can see here, and the reactions and everything. If you take this, then you can right click on this, means you can select a beam, this part of beam, and click on right click. You will get all the things. You will get the reaction, this complete beam. You will get reactions and movements at these points, SFD, BMD, and deflection curve. Okay, if you want to see for this beam, you can select this beam and right click, you will find the details. Now we want to look for our bending moment diagram. So moment at 3, apply. So this is the bending moment diagram for this. Okay, and that's all. This is how we analyze our beam in ETABS. So if you like the video, please like, share and subscribe my channel. Thank you.